Next problem, find the non-trivial solution of the homogeneous Fredholm equation g of s is equal to lambda into integral 0 to pi by 2 cos s sin t g of t dt. So we'll see the solution. Given equation g of s is equal to lambda integral 0 to pi by 2 cos s sin t g of t dt, that is equation number 1. So here the kernel k of s comma t is equal to cos s sin t. So it can be written as as into b of t, a of s into b of t. A of s is equal to cos s and b of t is equal to sin t, separable kernel. We know that ci, which is equal to integral 0 to pi by 2 bi of t g of t dt. But here we are having only one a of s and only one b of t. So we are taking ci is nothing but c and bi is nothing but b, right? There are not more than one term, that is why we are taking as it is, right? Otherwise you have to take a1s and b1t there, then you have to take c1 here, right? So avoid those things. I am taking directly c and b, right? So c is equal to integral 0 to pi by 2 b of t g of t dt. Substituting the value of b of t, so we will get integral 0 to pi by 2 sin t g of t dt. So substituting the c value, integral 0 to pi by 2 sin t g of t dt in 1, that is g of s is equal to 1 becomes lambda into integral 0 to pi by 2 cos s sin t g of t dt. Cos s is constant with respect to that particular integral. Take it outside, you will get lambda cos s integral 0 to pi by 2 sin t g of t dt. Integral 0 to pi by 2 sin t g of t dt is nothing but c from the previous step. So you will get lambda c cos s, right? That is equation number 2. So using 2 in 1, right, left hand side becomes lambda c cos s of equation number 1, because g of s is equal to lambda c cos s. So g of t is replace s by t, lambda c cos t, right? So substituting on the right hand side, because the g of t is inside the integral, right? Lambda integral 0 to pi by 2 cos s sin t lambda c cos t dt. So lambda c cos s is equal to, take it lambda c cos s outside from the integral. Already you are having one lambda outside, so lambda square c cos s integral 0 to pi by 2 sin t cos t. So lambda c cos x on the right hand side and lambda c cos s on the left hand side get cancelled. Remaining, you are having 1 in the left hand side, which is equal to lambda on the right hand side. Lambda into integral 0 to pi by 2 sin t. Cos t can be written as derivative of sin t. So we know t dt, integral t dt is t square by 2, right? Similarly here we are having sin square t by 2. So 1 equal to lambda sin square t by 2, lower limit 0, upper limit pi by 2. So substituting the value, right, upper limit, when sin pi by 2, right, sin square pi by 2, both are 1 only, right? Sin square pi by 2 is 1. So lambda by 2 is equal to 1. When our substituting the lower limit, sin square 0, right? Sin 0, sin square 0, 0, right? So you will get lambda by 2, lambda by 2, which is equal to 1. Lambda is equal to 2. So hence the solution of 1 is lambda s, which is equal to 2c cos s. That is the non-trivial solution. Next problem, find the non-trivial solution of the homogeneous Fredholm equation g of s is equal to 2 by pi lambda integral 0 to pi cos s of s minus t g of t dt. So given equation g of s is equal to 2 by pi lambda integral 0 to pi cos of s minus t g of t dt. So 2 divided by pi lambda integral 0 to pi cos a minus b formula, cos a cos b plus sin a sin b, cos s cos t plus sin s sin t g of t dt. That is equation number 1. So here the kernel k s comma t is equal to, k of s comma t is equal to cos s cos t plus sin s sin t. Here there are two terms, right? So first term a1s b1t. a1s is cos s and b1t is cos t, plus similarly b2s sin s and a2t sin t, right? Or a2s b2t, right? Not s b2t, right? So we know Ci is equal to integral 0 to pi bi of t g of t dt. So when I is equal to 1, here there are two terms, right? That is why we are substituting the values, right? Put I is equal to 1, C1 equal to integral 0 to pi b1 of t g of t dt. Substituting b1 of t value, you will get integral 0 to pi cos t g of t dt. Put I is equal to 2, C2 is equal to integral 0 to pi b2 of t g of t dt. Substituting the value of b2 of t, you will get integral 0 to pi sin t g of t dt. So 1 implies g of s is equal to 2 by pi lambda. So we are splitting into two integrals in one, right? So you will first integral 2 by pi lambda. So you will get cos s integral 0 to pi sin t g of t dt. So in cos integral cos s cos t g of t dt, right? So take the cos s outside because constant. So we will get cos s into integral 0 to pi cos t g of t dt. That is the first term. So cos t integral cos t g of t dt is c1. So substituting that one, so first term is lambda into c1 cos s. Similarly, coming to the second term, you will get integral 0 to pi sin s sin t g of t dt. Sin s is constant, take it outside from the integral. Sin s integral 0 to pi, right, sin t g of t dt. But integral 0 to pi sin t g of t dt is c2. So you will, second term you will get c2 sin s, right? So that is equation number 2. Using 2 in 1, you will get 2 divided by pi lambda c1 cos s plus c2 sin s, which is equal to 2 by pi lambda integral 0 to pi cos of s minus t 2 divided by pi lambda c1 cos t plus c2 sin t dt. So that is so 2 by lambda 2 divided by pi lambda get cancelled on both sides, right? So remaining you are having c1 cos s plus c2 sin s, which is equal to, already you are having 2 by divided by pi lambda inside the integral, take it outside, right? 2 divided by pi lambda integral 0 to pi cos of s minus t c1 cos t plus c2 sin t dt. So this is equal to 2 divided by pi lambda first integral. So here we are using cos a minus b formula, cos a cos b plus sin a sin b, right, into c1 cos t plus c2 sin t dt. Then multiply each and every term, right? So first term c1 cos s cos a cos b cos s cos t into cos t dt plus integral 0 to pi. Second term c2 cos s cos t sin t dt, right, second term. Then third term plus integral 0 to pi c1 sin s sin t cos t dt, right, plus fourth term integral 0 to pi c2 sin s sin t dt. Because in the previous step you are having cos s of s minus t, so cos s cos t plus sin s sin t. So there are two terms in that. Already you are having into c1 cos t plus c2 sin t. So multiplying 4 terms, 2 plus 2, right, first term 2 into 2, right, 2 into 2 you will get 4 terms. That is what. So 2 divided by pi lambda. So c1 cos s is constant, take it outside, integral 0 to pi cos square t dt plus c1 sin s is constant, take it outside, integral 0 to pi sin t derivative of sin t plus c2 cos s is a constant, take it outside, integral 0 to pi sin t derivative of sin t. Here cos t can be written as derivative of sin t in both the integrals, right? Then last one c2 sin s integral 0 to pi sin t into sin t sin square t dt. So 2 divided by pi lambda c1 cos s integral 0 to pi cos square t can be written as 1 plus cos 2t by 2 into dt plus c1 sin s sin square t by 2, right, derivative sin t into derivative of sin t. So lower limit 0, upper limit pi plus c2 cos s sin square t divided by 2 in the so lower limit 0, upper limit pi, because integral sin t derivative of sin t sin square t by 2. And last one c2 sin s sin square t can be written as integral 0 to pi 1 minus cos 2t by 2. So 2 divided by pi lambda c1 cos s by 2. So this can be written as, so integration of So 1 by 2 is there in the previous step. Integral 0 to pi 1 plus cos 2t by 2. Take the 1 by 2 outside, so you will get c1 cos s by 2. Then integral 0 to pi 1 plus cos 2t. So 1 plus cos 2t is the integration of 1 dt is t. Integral cos 2t is sin 2t by 2. That is t plus sin 2t by 2, lower limit 0, upper limit pi. Then here you are having limit. So whenever you are having sin pi or cos sin 0, both are 0. So the second and third term should be 0. Then last term c2 sin s, similarly you take 1 by 2 outside, so you will get c2 sin s by 2. So inside the integral you are having 1 minus cos 2t. So integral 1 dt is t, minus cos 2t is minus sin 2t by 2, lower limit 0, upper limit pi. Substituting the lower and upper limit, you will get 2 divided by pi lambda c1 cos s by 2, upper limit pi, right, lower limit 0, right. So you will get c1 cos s by 2 into pi. Similarly for the second term c2 sin s, upper limit pi, so you will get pi by 2. Whenever you are putting upper and lower limit for sin term, it will be 0. So you will get only one term, pi term. So c1 cos s plus c2 sin s is equal to 2 pi lambda c1 by 2 pi cos s plus 2 pi lambda c1 by 2 pi sin s. c2, right, second term is c2, instead of c1 you put c2. So 2 pi get cancelled. So c1 cos s plus c2 sin s is equal to lambda c1 cos s plus lambda c2 sin s. Comparing the coefficient of cos s and sin s, so you will get c1 is equal to lambda c1 and c2 is equal to lambda c2. So lambda is equal to 1. So both the cases lambda is equal to 1. Therefore the solution of 1 is g of s is equal to 2 divided by pi c1 cos s plus c2 sin x. Thanks.